Greetings, welcome. Let's continue with more examples on linear inequalities. Right, example 2 this time. So let's go right ahead and solve this example. Question is solve and sketch on a number line. Right. This is already in a standard form. There is 0 on the other side, and there's also you have 0 on the right hand side, and you have your equation on the left hand side. Okay, let's go right ahead and group this and then factorize. Let's factorize. From here we have x squared, which is common, and in the next one we have 4. Excuse me. Excuse me for that. We have 4, which is common. Let's go right on. So x squared, then we'll have 3, that x to the third power minus x to the second power. That will give me 3x minus 1. Okay. In that case, we'll take out minus 4. So we're taking out minus 4, this becomes positive 3x minus 1. Okay, all should be greater than 0. Now you're asking a question, but how did you get all these answers? How did you get 3x minus 1, and how did you get those to be the same? I'll explain that just now. You see, we found out that the factor is x squared. So to get the next term, or to get the terms inside the bracket, we just divide these terms that you have there by your common factor, which is x squared. This is what I did. 3x cubed divided by x squared gives us 3. And then with the x, if we are dividing and the bases are the same, x and x, subtract the power. 3 minus 1, so that's the same thing as 3x to the power 1, which is equals to 3x. We do the same also, x squared divided by x squared. Well, the bases are the same, these are the same letters, so we subtract the power. X squared minus 2, 2 minus 2, that gives us x to the power 0, which is equals to 1. That's how we got that. Then I did the same for minus 12x divided by 4. Well, what did I divide by minus 4? So minus and minus cancel out. 4 goes into 12 3 times, so you have 3x, the x remains. Then 4 divided by 4 gives you 1. That's how, but in this case it's minus 4, so it gives you a minus 1. Alright, that's how I got all those terms up there. So let's continue. Let's continue. Looking at this, we see that 3x minus 1 is common to both these terms. So we can factor out 3x minus 1. We have 3x minus 1 as a factor multiplied by x squared minus 4. Now you say, how did you get that? Well, Our factor is 3x minus 1. Okay, let me show you. X squared 3x minus 1 divided by 3x minus 1. This and this cancels out. I get x squared. I do the same for the second one. Minus 4 3x minus 1 divided by 3x minus 1. This and that one cancels out. Then you get minus 4. Minus 4, there's minus 4. X squared, there's x squared. That's how I got that. Okay, cool. So let's continue. Alright, from here, since we are factorizing, we don't have to use the condition as of yet, so we can just get the zeros just using the normal equal sign. So from here we are able to say 3x minus 1 is equals to 0 and x squared minus 4 is equals to 0. We covered why we're able to do that in the previous video. Well, because of this x squared minus 4 equals to 0. If I want 3x to be on its own here, I divide everything by x squared minus 4. I divide on the other side also by x squared minus 4. This and this one cancels out. I'm left with 3x minus 1 is equals to 0. Anything 0 divided by anything, you get 0. That's how we get this. The same also applies for if you want x squared to be on its own. Instead of dividing by x squared minus 4, now you divide by the one that you don't want to be on that side. 3x minus 1, x squared minus 4 equals to 0. In this case, we'll divide by 3x minus 1, 3x on the other side minus 1. Then we'll have this one cancelling out, and we'll just have x squared minus 4 equals to 0 on its own. That's how we get that, okay? So don't ever get confused. Now that's out of the way, we can continue. From here, we can be able to solve for the zeros. So I want to solve for x. So I'll move this one to the other side of the equal sign, and if it jumps the equal sign or an inequality, the sign changes. In this case, it's -1, so if it jumps the equal sign, what does it become? The sign changes to positive. It can only change to positive or negative. Since it's negative, changes to +1. There's no need to write +1. Just leave it as 1. Therefore, I want x to be on its own. I divide by 3. I divide by 3 on both sides. 3 and 3 cancels out. You have 1 there, 1 down there. So x is equals to 1/3. So this is one of our zeros. Okay, what else? Well, let's solve the second one. We want x squared to be on its own. Well, x squared, this guy moves to the other side. The sign changes to +4. Since it's squared, we'll square root this side. If we square root one side, we'll also square root on the other side. Square root this, the square root cancels out with the 2. How does that happen, you say? Alright, this is how it happens. X squared, square root of x squared is the same thing as writing x squared. That's exactly what we have there. X squared, the square root is the same thing as raising any number to the power 1/2. And when you do that, you will see that there's an indices law that tells us that if you have a base raised to the power raised to another power, you just multiply the powers. In this case 2 times 1 over 2, therefore you have x to the power 2 multiplied by 1 over 2, so x to the power 2 over 2, which is the same thing as x to the power 1, which is equal to just x. So that's how we get that. That's how the square root cancels out. Cool. So square root cancels out. X is equals to plus minus. Since it was a square root, it means we'll have two answers. So that's why we will have one will be positive and one will be a negative one. Square root of 2 is 1. I mean square root of 4 is 1. I said it already, it's 2. So right there we have two answers, positive 2 and negative 2. So the roots or the zeros for a given equation are as follows in ascending order. X is equals to minus 2 is the list of all of the zeros, followed by x is equals to 1 over 3, followed by x is equals to 2. What really is 1 over 3? Well, let's look at it. X is equals to 1 over 3. What really is that? Well, 1 divided by 3, it cannot, therefore plus a 0 point. Okay, so if I put plus a 0 there and then I plus a 0 there, how many times does 3 go into 10? Well, 3 times, but then it leaves a remainder of 1. 3 goes into 9 3 times, so 3 remainder 1. I'll be like, okay, how many times does 3 go into 1? It cannot. Plus a 0, there's already a 0 there, just put plus a 0 there. How many times does 3 go into 10? 3 times, remainder 1. So that continues, 3 into 10, 3. So it's recurring 0.3333 until infinity. Does not stop. 0.33. So this is the same thing as 0.33 if you wished to write 0.33. We'll just leave it to 2 decimal places for now. So now, as always, we'll look at our number line. We can already see number line will be divided into how many sections or how many regions. Let me draw it properly. Number line will be divided into 4 regions as usual if it's a cubic equation that you're solving. In this case, we'll have one region minus 2. Second region will be 1 over 3. And the third region would be 2, and fourth region will go all the way to infinity. So there you have it. The regions are minus infinity, from minus infinity to minus 2, that's the first region. Second region is from minus 2 to 1 over 3. And the third region is from 1 over 3 all the way to 2. Fourth region is all the way from 2 and it goes to infinity. So what's our given condition? Our given condition is as follows. Given condition states that 3x minus 1 x squared minus 4 should be greater than 0. Okay. previous work from the previous video. Let's go. 3x minus 1 x squared minus 4 should be greater than 0. That's our condition. Three x minus 1 x squared minus 4 should be greater than 0. X minus 1 x squared minus 4 should be greater than 0. So let's get some testing points. We'll test minus 3 here, and here we'll test 0, and right here we'll test 1, and there we shall test 3. Let's go on and do it. If x is equals to minus 3, what's our answer here? So 3 multiplied by minus 3 minus 1 multiplied by minus 3 squared minus 4 should be greater than 0. 3 by 3, that's minus 9, minus 1, negative 3 squared, that is 3 times 3, that is 9, minus 4 should be greater than 0. Minus 10 multiplied by 9 minus 4 gives me 5, should be greater than 0. Here we have minus 50, which is not greater than 0, so the condition is not met in this region. We'll move on to the next region. Move on to the next region. There we'll test out 0, and we'll have 0 minus 1 and 0 minus 4 should be greater than 0. Negative 1 multiplied by minus 4 should be greater than 0, should be greater than 0. Negative 1 and negative becomes positive, so positive 4 is greater than 0, so the condition is met in this region. However, the sign we have is that it should be greater than 0. The zeros on the number line are not included, so let's go ahead and plot this one. It looks like in this region to be from minus 2. Minus 2 is not included in the conditions, so all the sets of values, from minus 2 to 1 over 3 will give you the correct solution. Okay, so that's the first plot. What about the third region? Is the condition met in the third region? Let's find out. X is equals to 1. That's what we are using. Minus 1, 1 squared minus 4 should be greater than 0. 3 minus 1 multiplied by 1 minus 4. Already we can see 3 minus 1, that's 2. 1 minus 4, that's minus 3, is not greater than 0. 2 times minus 3, that's minus 6, which is not greater than 0, which is exactly less than 0. Therefore, the condition is not met in this region. Okay, so we move on to the next region. Condition not met. We use 3 in this region. 3x is equals to 3 minus 1, 3 squared minus 4 should be greater than 0. 3 by 3 multiplied by 3, that's 9 minus 1. 3 squared, that's 9 minus 4, should be greater than 0. Is it greater than 0? 9 minus 1, well, 9 minus 1, that is, gives us 8. And 9 minus 4 gives us a 5. So 5 times 8 which is a 40, because 5 times 5, that's 25. Okay, 5 times 6, that's 30. 5 times 7, that is 35, and 5 times 8, that's 40. 40 is greater than 0, so the condition is met in this region. Therefore, we say okay, we cannot plot it like that. The whole states that 2 is not included in the set. Okay, so all the sets from 2 going all the way to infinity, that is 2.1, 2.2, 2.3, 3, 4, 5, 6, 7, all the way to positive infinity, will satisfy or will meet the condition, will always give you an answer greater than 0. Therefore, the condition is satisfied in this region. Our domain, therefore, is, okay, you can plot it like this, or you plot it like this. That all the sets from 2 going all the way to infinity meet the condition. Oh boy, that's not good. So yeah, we're finishing off now. So region is from -2 to 1/3, union 2 all the way to infinity. That's the set of value that give the correct solution. Alright, that's it for this video. Come again for rational inequalities.